Despite their huge size, there remain many aspects of manta ray biology and ecology that we still don't understand. Many of the unanswered questions involve manta ray reproductive ecology. For example, how often they reproduce, how quickly they grow, and even where they give birth.
Manta rays face an existential threat. Together, let's create a healthy, balanced ecosystem for these amazing creatures, for our oceans and of course, for our planet.
When it comes to female manta rays, there are a couple of external visual clues that allow us to determine whether they're mature or immature. One of them is the presence of a pregnancy bulge. Basically, as female manta rays become pregnant, after about 6 months into their gestation, the belly swellens just like a pregnant woman. Female manta rays give birth to only one pup at a time, and the pup at birth is at least 1.2 up to 1.5 meters in wingspan. The pup inside the womb of the mother has its pectoral fin folded one on top of the other behind its back. Into the third trimester of gestation, the womb of the manta enlarges to a point where it becomes visible and easy to be detected simply visually.
During copulation, the male will bite down on the left pectoral fin of the female in order to mate. This leaves a fresh ventral mating wound on the underside of her pectoral fin and tells us that she has recently mated, but these will fade over time. The arches on the mouth of the male also can leave scarring on the dorsal side or the top side of the pectoral fin of the female, and these can last a lifetime.
But what if a female is not visually pregnant and doesn't display mating scars? Until recent years, there was no other way to determine whether they are mature or whether they're pregnant. But thanks to technology development of the last years, we are now able to detect early gestation and early signs of maturity. We're now using a newly developed ultrasound unit, small, compact and light, to determine whether the individuals are mature and or pregnant. So what we've got here is a contactless ultrasound unit, and this is what we use to scan wild manta rays in the natural environment. It comprises the actual ultrasound, the scanner, which is here. The ultrasounds are actually released by the probe, which is right here at the end. And the images are actually recorded on a mobile phone, located in here in a waterproof case. So we can actually see what we are scanning directly underwater. I also have a GoPro mounted on the rig, which allows me to film what I'm scanning when I'm scanning it, so I can sync the sonograms, the images that I got on the ultrasound with the footage taken by the GoPro, and I know exactly what I'm looking at, which area of the manta I'm scanning as I'm looking at the images. What we found so far is that The uterus is visible on ultrasound only in sexually mature individuals, and so we can use that as a sign of maturity. Based on these preliminary findings, up to 1 in 4 individuals have been wrongly identified as immature while they're actually mature.
This means that reproductive potential is higher than we originally thought because there are more mature females within the population. However, the proportion of females actually pregnant at any one time is lower than we originally estimated. Another aspect we are looking into is growth rates, size at maturity, and the difference in sight use between adults and juvenile manta rays. By using stereo video photogrammetry, we can accurately measure the wingspan of manta rays. This is a stereo video photogrammetry device. It's 2 GoPros perfectly calibrated at a certain angle, pointing this way at the manta. It allows us to film the manta at these 2 different angles, and from this we are able to get an accurate measurement of their wingspan. This non-invasive technique has proven to be more accurate than other methods previously used.
So our plan is to measure the same individuals over a number of years to gather precise growth rates estimates, as at the moment it's quite difficult to establish the age of an individual based on its size alone. By combining measurements of individuals with ultrasound examinations, we will be able to gather more accurate estimates of sizes at maturity for both males and female. We are also taking measurements of manta rays at different sites across the country to gather a better understanding of how different size mantas are utilizing different sites. We are particularly interested in finding potential nursery sites for manta rays across the country. Identifying and protecting these sites would be vital to the long-term survival of these animals. We have measured over 200 individuals in the last 3 years and have identified the first potential nursery site for manta rays in the Maldives. The manta rays measured at this site are smaller than 2.4 meters in wingspan, which is significantly lower than any other sites from where we've collected measurements of mantas from. The opportunity to survey the northern region of the Maldives has given us the chance to gather better information of fecundity and size distribution at locations from where we had no previous data from. We have also been able to gather baseline data that in the future will allow us to potentially determine the presence of further nursery sites.
It was insane. We had easily 20 different mantas coming in, going out. We got ultrasound of many females, we got measurements. It was epic.
In order to protect any species, it's fundamental to understand their basic biology and, more importantly, their reproductive ecology. Only once we understand these aspects, we can design more effective conservation measures to ensure the long-term survival of the species.